Hello everyone, welcome to my talk about, well, we all grow older, but our projects really have to. I'm Simon Verhoeven, let's see, and I'm a Java consultant, which means I come in contact with a lot of different technologies, and I've worked on a lot of different projects over the past couple of years. And just like our favorite doctor, that means a bit of time travel every now and then. Sometimes we go from a Java 17 project to Java 11 project to Java 8, back and forth. And at times that poses some challenges because just like everyone, I'm very excited to hear about all the new developments at DevOps this year, virtual threads, better matching, sequence collections, etc. But of course, that raises the question. We all have these new toys that we all want to play with, but how do we actually get there? Because our projects do need to be upgraded every now and then. Some of you might still be using Spring Boot 2 and want to upgrade to Spring Boot 3, which of course also means an upgrade from Java 8 to Java 17 at the very least, since that's a new baseline, which also means that a lot of other changes down the chain need to be done. For example, Java X to Jakarta, Spring Boot, Spring Security, and Hibernate. Now, of course, that entails a lot of different challenges, and I hope some of you are also aware of these. For all these different packages that you need to upgrade, and that's where a tool like OpenRewrite can come in, because you can do all these changes yourself, but of course, then you need to dive in into all the release notes, figure out all the updated properties, all the breaking changes that might have happened over the past couple of years. So Java X to Jakarta, the deprecated properties, and all the new features, of course. OpenRewrite itself is a tool that originally started at Netflix, where they initially used it to migrate their logging framework to SLF4G. Now, Netflix itself has a whole slew of repositories, over 10,000 repositories. Of course, you can manually update all these repositories yourself, but that's quite a bit of work, as we all know. So you want to do this preferably somewhat automatically, but of course, Netflix itself, if a service goes down, you'll get a lot of complaints. So you need a very good and automated transformation, and that's where the tool initially started. And in 2018, the tool itself got open sourced under the Apache license 2.0. So OpenRewrite itself nowadays is for mass transformations of your application at large scale. It can do a whole lot of different things. And it's not just for large organizations. You can also use it as a framework developer or even as an individual developer to do minor changes to your application. So it can go from very large-scale applications, migration, so Spring Boot 2 to 3, somewhat smaller changes, to even very minor things like, say, you need to update all your package names from Java X to Jakarta for some legal reasons. So you can use it for the fixes, migrations, or you can also do it for Sonar fixes, or also utility things like generating your BOM file, dependent on your Maven file, of course. So how does it work? There are a couple of different ways that you can do transformation. You can just do a text-based search. You can use an abstract syntax tree, but the way that OpenRewrite works is a lossless semantic tree, which means your code gets reversed through, and it gets analyzed, and your visitors get created. Now, as you can see at the right side, it does get very complex, but all these informations get used. So we can detect what kind of changes are needed, and then we can make these adaptations into your different recipes, which will be used, and to determine what changes are possible, what are needed, and to change these different recipes. It's a very large and growing ecosystem. You can see it's used for Java itself, Groovy, Gradle. It's a tool that can be used both using Maven as using Gradle. Kotlin is also supported nowadays, although the migration for Kotlin projects themselves is still under development. But you can also use it to update your GitHub Actions, your Terraform scripts, or even some SQL files and YAML files. Now, recipes themselves are collections of operations that will be performed upon the lossless semantic tree, and they are composable. So you can change the different recipes together to achieve quite a large transformations at scale on your repository. And I'll showcase, later on I'll showcase some of the different things you can achieve. And at the end, there's also time for some questions if you have some. Now, the visitors themselves determine what and when will be performed upon your repositories, which is based upon the lossless semantic tree that we saw earlier. Now, the modules themselves, these group repositories, and they can do complete migrations. They serve a specific purpose, just Spring or testing frameworks, and they get gathered in a different module. Now, these are also iterative. So there's, for example, a Spring Boot 3.1 module, which will also take into account the migration to 3.0, starting from 2.7. So if you want, you can do incremental steps, or you can immediately go to Spring Boot 3.1. This is an example of the recipe file that is used for Spring Boot 3.1. As you can see, it's actually composed of different recipes. Recipe to upgrade to Spring Boot 3.0, and also the upgrade of the dependency version in our different files. Then the upgrade to Spring Security 6.1, and of course, the upgrade of the Spring Boot property files themselves, and the upgrade to the new Hibernate version. This is a bit of a simpler step to showcase a bit more what happens with a very simple recipe. This is just the common statistic analysis recipe, which you can use to analyze a project for certain common issues that might get pointed out on Sonar or Kin, such as empty blocks, or that the default comes last, or that things should be final, or the modifier order is incorrect, which will then also automatically apply these fixes. Now, one important thing to keep in mind is there are multiple ways to run OpenRewrite. You can either use it through the command line, or using a recipe file itself. In the sense of, if you use it through the command line tool, you don't need to update your build files themselves, but these are for the parameterless builds. Some recipes that you want to execute, just as renaming packages, do require some input, and then you'll need to create a recipe file yourself to provide these input parameters. Now, one advantage of OpenRewrite itself is that it's very easy to test. This is, for example, the test case that's used for the top level properties. As you can see here, the constructor bind is no longer needed in the newer versions. So here we test the recipe itself for rewrite run for Java. And this is the initial input, and this is the expected output. Now, the way this OpenRewrite itself behaves is it creates a diff file by itself, or a dry run if you want to. Now, I'm going to start quite easy for my demo itself. So I set up a very basic project which contains some common issues. And I'll start with a simple task, the naming of my organization name itself. This is an action that doesn't require any input by default. Well, sorry, it requires some input, but there are a couple of ways to run it. But let's first start with something very easy, removing unused imports. So here in my demo application, I was a bit sloppy when I committed things, so I have an unused import, which is annoying. I can do it myself, of course. I have a decent IDE. But if you have a larger repository, it might be nice to do it somewhat automatically. So now I'm executing this using Maven. And now, of course, it's going to scan my complete project, get a lossless semantic tree, see if there's anything that needs to be executed. Now it's taking a bit of time for some reason. Usually it's quite fast, but in the output we'll also see which recipes are active and then what was actually executed. So now it ran. Here we can see the changes that were made, and we see that 2 files were updated. Now if I do a git diff, we also see the changes that were applied. So this is a very easy recipe that was used, didn't require any input for ourselves. Now something a bit more advanced is if you want to do something a bit more complex, is you can write, so this used this recipe file. As you can see itself, I gave the name, a display name, so it's a bit more visible. And here you see the 2 different arguments that were expected by the change package recipe. So being the old package name and the new package name. So let's execute that one. So here I can go to my POM file and I'll activate different dependencies. So the way, if you're using Maven, that you do it is you add the rewrite Maven plugin. And first of all, you have the dependencies. So these are the different modules that I mentioned earlier in the talk. And let's start with a sample recipe. As you can see here, it's also possible to activate the recipe in the file itself, but since the remove unused import doesn't require any input, you can just as well do it through your command line. Now let's run this recipe. It's again going to scan our project. And let's see. Here we can see that there's one active recipe, sample recipe. So sometimes you might get some odd behavior. I've seen some questions pass by on the Slack channel of OpenRewrite, and people sometimes make typos in their recipes, and then they weren't activated, of course. So now here we can see which changes were made, and here we can see that the different files were moved from our old package name to the new package name. So if I now go to my IDE and it refreshes, I'll see that nothing was broken and everything is now present in the new org name. Of course, these are all very minor changes. And sometimes you might want to do something a bit more complex or more advanced. For example, say we want to modernize our application a bit further. Now this demo project that I set up is a bit on the older side, which might be familiar with some people. In fact, it's still a Spring Boot 2.7 project using Java 8. As you can see, we have quite a bit of old and more vulnerable dependencies. We're still using Log4j 1.2. We're even using Guava version 20, which has some security concerns, and we're using Hamcrest. Now, Hamcrest itself isn't actively developed anymore, so it's usually a good idea to start moving towards SRTA. Now we can do all these adaptations from Hamcrest to the SRTA methods ourselves. It's not that much work, but if you have, once again, a bit more test, it's nice to do it yourself and not have to do it yourself. So we can make use of the testing model of OpenRewrite, which also contains migrate Hamcrest to SRTA. And it seems that some new versions of OpenRewrite were pushed. And this recipe will scan all our different tests, look for the imports, and use methods, do some analysis to determine which are the best replacements for to use test methods, and then also update both our POM file and the Java classes themselves. So here we can see that my git hemcast to SRK was run, that a dependency was added, which is part of the composition of the recipe. Because, of course, if you mark it to SRK and you don't have the dependency yet, then it will be added. And then we can see that these changes were applied. So it detected that we were using equal to the creator 10 method, has items, etc. of OpenRewrite. So here we can see all the different changes that were made by OpenRewrite for us. These aren't the most advanced test cases, of course, but it's nice to see that all these changes were made for us. For example, assert that is now ideally here can be true. Less than or equal to 1 within hemcast is the same as is less than or equal to 1 in assert, etc. Now, of course, in the path forwards to Spring Boot 3, of course, at the time of Spring Boot 2, when we developed the application, we were still using Giant 4. Moving forward, you might want to make use of Giant 5, of course. And once again, this entails some changes to Jupyter. And luckily, once again, there's a recipe for us. Now, I'll say in advance, these recipes aren't perfect, they aren't complete, but more recipes are being added every day. And OpenRewrite itself and Moderna always welcomes contributions. Of course, one of the advantages of OpenRewrite itself is this analysis can take a bit more time for larger projects, but it's possible to reuse this analysis later on in the project if you want to. In this case, I didn't set it up because it's a smaller project. So here we can see that the Giant 4 to 5 migration, it removed the older dependency, added a new one, and some changes were made to make use of the new features. And OpenRewrite itself is, of course, also kind enough to remind us, please review these changes and commit the results. So it won't change your code base automatically. Of course. So here we can see some of the new things. So create them file, assert rows, etc. And after class is now after all, before has become before each in JUnit 5. Now, you can of course always see the documentation yourself, but for a larger project, it's very easy to miss one minor thing. Now, of course, this is all very fine and dandy, but you want to go even larger. After all, why migrate all these different dependencies yourself? When you want to go from Spring Boot 2 to 3.1, we know what we want, we know what we need. So there's no need to do all these changes yourself individually. This is where the recipe that I mentioned earlier comes in handy. Upgrade Spring Boot 3.1 will do a whole lot of these things for us. Because yeah, Spring Boot 3.1, new baseline of Java 17, includes new Spring security, the new filter chain changes, Hibernate 6.2, which has some interesting changes to the properties as well, which can be quite a headache if you have to do it yourself and need to keep every little thing in mind. And as you can see now, we got quite a bit more output. So here it's actually, I like reading this myself, but might not be for everyone. But here you can see a very nice chain of what actually happened. because we know we specified upgrade to Spring Boot 3.1, but here you can clearly see that this also entails the migration to Spring Boot 3, 2.7, 2.6, and the whole chain down, which also includes the upgrade to Java 17, which is actually a composition of Java 8 to 11. In case you were even using an older version, you're still using Java 6 or 7 maybe. Although hopefully not, but never say never, of course. Is someone actually even still using Java 6, 7, or 8 in production? It's time to start migrating. Especially, yeah, the support ended. There are some very nice features that I got added, but of course. And also, I think you might even start getting issues if you're making use of Turkey, because if you update the JDK, it also contains changes to the locale and the country and currency. And Turkey, of course, changed name, I think now a year or two ago. So if you want to use a new official name, you might hit some challenges with Java 8. So we can see it also. Let's actually go here, which is a bit nicer for everyone. It's a bit more visual. So here we see we're now also making use of the new Spring Boot 3.1 annotations rather than the older Spring Boot 2 annotations. Now another thing, I don't know how everyone else feels about it. I know, for example, that Mario Fusco has some IDs on Lombok and Java. I myself, ever since the introduction of Java 11, 17, Java has its uses, but a lot is now part of the core JDK. So when possible, I try to move Java myself, migrate away from it. Since a lot of time, the less the external dependencies I have in my project, the quicker my builds, and it's just extra overhead for people, especially younger people that haven't worked with Java yet. Let them use the new nice features of Java 17. So it can be used to change. Yeah, of course. It seems that one thing got skipped. A bit annoying. Well, not all recipes are perfect. Let's raise a pull request for that later on and see if we can get that fixed. But yeah, you can use it to modernize, or you can use it to migrate your project so away from Java or from Helmcast SRJ. Or if you're feeling adventurous, to migrate from Quarkus to Spring or the other way around. Of course, there are also other things you might want to do on your. Let's see. Let's first run this recipe again. It's quite aptly named No Java. Please keep it that way. Of course, this is also why you want to start compositioning your recipes together and setting it up in your POM file or in your build file, so that you don't actually have to do this individually every time. So now here we can see the changes that were made. Yeah, if you have an older project, Java 6 or 7, you don't have quite the optionals yet, so the Java optionals might have been used. We now have optionals as part of the JDK, so let's make use of that. We have bigdecimal, which also means we no longer need to make use of these Java libraries. Well, functionalities, of course. And we also have our own list of, so no need for the Java immutable list of. Of course, let's see, 5 minutes left. Have to speed up a little bit. Let's keep up a little bit. One thing I quite like myself about OpenRewrite is it's not only for your project itself, you can also use it for GitHub, for example. If you have your runner files, you can also use different recipes to upgrade your build files themselves. For example, we upgraded our project to Spring Boot 3.1, so we also want to make sure that our build on GitHub, for example, makes use of these versions. And for that, there are, of course, also recipes. And while that's running, I'll skip a little bit ahead. It also has some convenience functions recipes. I hope that you don't need them, but I know at certain organizations, people accidentally do commit secrets to their repositories, and as well know, people try to use all kinds of keywords or variable names for these secrets or password. PW, password, token, secret, hash, etc. So these can be quite a challenge to find. Now, OpenRewrite actually has a convenience recipe for that. For example, there's a recipe to find Azure secrets. As you might have seen earlier in the presentation, I did hide one secret in here, the account key. Please don't do this. I'm still getting mails from GitHub every time I commit to this repository. I'm thankful for those emails, but when this recipe finishes, then OpenRewrite will add a marker for us so we can easily find these issues in our file, which will also make it a lot easier for us to scan our repository. So here we can see OpenRewrite added this command for us. That's your access key, which makes it a lot easier to find than just hoping to find the correct variable name or token name or property name. So one of the OpenRewrite itself also is built upon a couple of principles. You can achieve quite large migrations in small usable steps, like you saw earlier, to upgrade from Spring Boot 2 to 3.1, which spans almost a decade by now. It's important every execution will have the same result or the same base result. It might be there are some extra changes if some recipes got added to a new one. There's also no code leakage. So if you want to run it locally, OpenRewrite itself doesn't receive any of your data. It's a concern of some people, but no code gets committed or leaked to OpenRewrite itself. Now, OpenRewrite itself is continuously evolving. New recipes are being added. There work on refactor-like templates. New languages and ecosystems are continuously being added. So the support for Kotlin and Python is being expanded, and they're working on more CLI integrations. Now, besides OpenRewrite itself, there's also Modern, which helps support OpenRewrite, and that can be used. It's a platform that you can use to apply these recipes yourself on different repositories. It's as a service. It's free for open source projects and paid for non-open source projects, of course. And you can see it has been executed on quite a bit of projects for a very large ecosystem. So there you can actually quite easily select different recipes that you want to execute, or even add them yourself and have them execute on your repository, which is actually quite convenient. Now, of course, as much as I like OpenRewrite itself, I'm also a fan of an apple a day keeps the doctor away. So OpenRewrite itself is nice, but please do consider also taking a look at some nice tools like Dependabot, Renovate, or Sneak, which will help you keep your dependencies up to date and also nag at you if you do commit some security vulnerabilities. And these are you can just make them part of your build pipeline, and they make your life easier. Now, in case you're interested, there are 2 other talks at DevOps this week about OpenRewrite. One's in the room next to me, so that's a bit late, but it's always nice for the video recording itself, is OpenRewrite and GT for transforming large application. and there's a session by Tim de Beek from Modern Tomorrow by maintaining Maven at scale, which is used to update Maven 3 and 4 currently, with some very nice results, which will be tomorrow at 20 to 5 to 5:30. Now, in case you're interested in learning more, these are links. There's a very nice documentation site. It's also GitHub. You can make use of the Modern site, and there's a very active and helpful Slack community. Now, in case you're interested in the code itself behind the different demos or just the different commands that I used, this is a QR code for the project itself, which you can make use. I just commit on an open source license, so you can use it as you want. If you want to make use of it for your own demos, feel free. And if anybody has any questions.
Do the recipes usually update Docker files?
There are some recipes to update Docker files. There are even some recipes to update plain text files, so you can analyze all kinds of files. Not sure if there are any other questions. And thank you for attending.